Hello and welcome to How Do I Determine the Subgraduates on a Graduated Cylinder. First off, we have a 100 milliliter graduated cylinder here on the left. Collar is up, protecting it. We have a similar graduated cylinder zoomed in over here so we can see the numbers a little bit better. In both cylinders, you can see we have these large numbers sitting on these big lines. Those are called our graduates. Those are our known volumes. If the meniscus measuring is sitting on one of those lines, we know what the volume is. In between, we have unmarked lines. These are the subgraduates. And the question is, what is the value of each of these little smaller lines? Now for this example, I'm going to use the value I'm going to tell you is 1 milliliter each line, meaning 50 plus 1, 51, then out center plus 1, 52, 53, 54, 55, 56, 57, 58, 59, 60. This one is pretty easy. I'm using it as my example, so when you see me go through the math, you can use it on a more difficult one. So here it is. I'm going to show you mathematically how to do this. So when you hit one that's not easy, you know how to do it. So first thing you have to do is subtract the two known graduates, 60 and 50. It doesn't matter which two graduates you pick, just pick two. You can even, if you had 40 or 30, you could have picked those. I'm going to show my math here because I'm going to be a good math student. I'm also going to put my unit on my numbers, being a good science student. So 60 minus 50, the difference between those two numbers very easily is 10 milliliters. And then I'm going to divide that by the number of spaces in between the known graduates and the subgraduates combined. And what I mean by that is I'm going to count how many spaces appear between the graduates, 50 and 60, and all the subgraduates in between. So I got to count them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So I have 10. So I take 10 milliliters, divide it by 10. Each line, as we already knew, is 1 milliliter each. And you might wonder, why don't they just put that here? It's because it would cause a lot of clutter and make it hard to read. In fact, you can see the 50 alone for us to see it has this big line it's sitting on, plus it's next to these three littler lines. So what this verifies is what I said earlier. Each of these lines is plus 1 milliliter. So if this is 50, plus 1 is makes this 51, 52, 53, 54, 55, 56, 57, 58, 59, 60, and it just, by doing that, we confirm our math is right. Let's look at a little bit harder one. We have our known graduate here of 20 sitting on this line. We have our other known graduate, 25, sitting on this line. So I subtract the two. $25 milliliters. Again, being a good math student and showing my work, being a good science student and showing my work with units. Subtracting the two, I get 5 milliliters. Now I need to count the number of spaces. Here's my 20, it's sitting on this bigger line. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 spaces again. But this time, it's not over 10 milliliters, it's over 5 milliliters. So 5 divided by 10 means each line on this one is worth 0.5 milliliters. So that means if this is 20, this is 20.5, 21, 21.5, 22, 22.5, 23, 23.5, 24, 24.5, and then there's our 25. And again, we're checking our work by counting up by 0.5s, and it fits the scale of our graduated cylinder. I hope this helps you determine subgraduates on the science tools we're going to be using in this unit. If this video wasn't good enough to help you figure out how to determine the subgraduates, please approach me and I will do a live demonstration with one of our graduate cylinders in class.